they attract. And that attraction is the ionic bond. 2 chlorides, and we will have 1 magnesium cation. We are talking about ionic bonding in this video, and you guessed it, it's when ions bond together. So how do ions form in the first place? Well, it's all about the valence electrons. We just learned about the octet rule, so let's put it all together. So metals tend to give up electrons quite easily, and nonmetals attract electrons. So I have marked on this periodic table the metals and the nonmetals. Don't forget that hydrogen is a nonmetal. So what happens? Well, I have a metal here, sodium is an example, and then we have a nonmetal, chlorine. So how does a bond form between sodium and chlorine? Well, the sodium atom is going to, we're going to transfer that electron literally from sodium's orbitals. Which electron? That one lonely valence electron, this guy right here. And he is going to go where? Right there. So what's going to happen to sodium? What's he going to become when he transfers that electron? Well, this is gone, and look what I have now. The electron configuration of a noble gas. Now, when chlorine gains that electron, now what happens? Instead of 5 electrons in the p orbitals, now I have 6. And guess what that looks like? The electron configuration for argon. So he looks like a noble gas. So let me draw this. Now I have the sodium ion. Since I've lost an electron, I have a +1 charge. And then chlorine now is an ion called chloride, and it has a -1 charge. So I have an anion and I have a cation. And these are oppositely charged particles, and what do? They attract. And that attraction is the ionic bond. Memorize that definition of an ionic bond. It's the electrical attraction between a positive and a negative particle, cations and anions. Let's do a couple more of these. You need to be able to show that electron transfer. So my metal is going to give up an electron. He's going to give up that electron right there, but chlorine is now stable. Chlorine is now the chloride ion because he now has 8 valence electrons, but the magnesium still has a valence electron to get rid of. So we're going to need another chlorine and to accept that other valence electron. And so now I'll have 2 chlorides, and we will have 1 magnesium cation. So they will always work out such that all the valence electrons will make everybody stable with 8 valence electrons. Let's do aluminum and oxygen. How would those two bond? Well, the metal is going to give up electrons. Oxygen can take 1 here and 1 here. So now the oxygen forms oxide, and he's stable, but the aluminum still got 1 to give. So we'll need another oxygen atom. Sorry, let me make one here like this. And I've got 6 valence electrons. Well, I can take 1 right here, but that oxygen still needs another valence electron. So we're going to need another aluminum. And one of those valence electrons can come here. So that oxygen's good. Well, now that other aluminum has 2 more electrons to give. So guess what we need? We need 1 more oxygen atom. And so 1 of them will go here and 1 will go here. So now I have everybody stable. I made 3 oxides and I made 2 aluminum cations. And since they lost 3 electrons each, they have a +3 charge. I know that looks a little crazy. You think, is there an easier way to do it? There is. Look at these formulas here. 1 sodium, 1 chloride. The magnesium needed 2 chlorides. I just showed you why right here. 1 magnesium and made 2 chlorides. And then look, 2 aluminums, 3 oxides. There's aluminum oxide. So there is going to be an easier way to do this. We'll get there in the next video. But First of all, I want to just give you a couple of the properties of ionic compounds. They typically, most of them actually look like this, white crystalline powders. They're crystalline, they have kind of smooth, sharp edges, and if you think table salt, generally most ionic compounds look like that. Some have a little bit of color, different properties, but generally they look like that. High melting point, very high melting point. And then they will often, many of them will dissolve in water and form what we call an aqueous solution, and that solution will conduct electricity. Why might it conduct electricity? Because it contains cations and anions, which are electrically charged particles. So I hope that gives you a good introduction to ionic bonding and ionic compounds. In the next video, we will continue to write formulas and name compounds.